for that. Bell rang before Jack came out.
Yeah.
Yeah. Is that a pass?
It's not I stopped to talk to Army Jack.
Mr. Army did.
I got a number for you.
See a number? Is that going to count?
Ask him.
Oh, Jack. Yeah, I mean, I don't know. Maybe that was worth. Maybe that was worth not giving the target bonus points. I don't know. Maybe, probably. All right. So let's let me just go through a couple of things here quickly, and that may take care of some of your questions that you might have. But so this transformation. So first we got the quiz. I want to go through the things that are going to be on the quiz, and I want to have a chance to talk about that for sure. And so I don't want to get too caught up in this stuff with transformations because we ran into one there at the end that we kind of need to talk about. It was a little tricky on how it happened. Was this one here, but I'm not going to go into great detail on the quiz tomorrow. The quiz isn't going to be real long. We're probably not going to spend time reviewing very much tomorrow before the quiz. Because we have lunch, we have 50 minutes and then lunch and then 30 minutes after. Now, I'm not quite sure how that's going to work on quiz days, depending on how long I think the quiz might be. What I do know is whenever we start the quiz, we will finish the quiz before we leave the room, okay? So that means if we're going to do it, so my plan tomorrow is to do it. I think 50 minutes is plenty of time for this particular quiz. If you're still working on it after 50 minutes, then it probably doesn't matter, okay? If you're still having to figure some things out, you're probably not going to figure it out with another 50 minutes or 100 minutes or whatever, okay? So that's what we're going to do. Now, what we might do, though, on quiz days is we might say, today, or, I might say, hey, tomorrow's our quiz, go to a lunch. We'll come back and then we'll do the quiz, okay? And then we have more time, just in case, right? That kind of thing. So sometimes I'm going to cut it off and say, okay, you only get this much time. You need to be done that much time, or whatever. Maybe we'll do D lunch. I don't know. We'll talk about what we think's better. We'll just stay for that entire time. Now, I don't know if we're supposed to do that. I don't know. But right now, my plan is to not ask permission. We'll just do it. we get in trouble, I'll ask for forgiveness. Okay? So we're gonna, but for tomorrow, we'll just do our normal thing. So the plan is, so if you've got questions, then I would try to get up earlier in the morning and come see me, okay? Because I will be here before school, okay? So if you've got some questions. All right, now, so let's talk about these transformations. So this is just one part of the quiz, and I'm not going to have a bunch of graphing on the quiz. You're not going to draw a bunch of graphs and things like that. I'm probably going to do more of the describing what's going on or writing of the equations. I tell you what's going on and maybe give you a picture and then you tell what's going on, that kind of thing. I'm not going to spend a lot of time graphing those kind of things. So like if I gave you this to be able to describe it. Now you want to describe it in the order. So that's why I'm going to talk about it real quick. The transformation is happening. So what's happening on this one? So if I say describe the transformation, you would write down what? In order though. And I would use the word shift. Shift right 4 happens first. You always go to the inside first. Right 4, flip vertically. I'm okay if that's all you say. Now you can say reflect. You can say a vertical reflection, okay, but that's a flip, okay. That's the negative. What's the 2 do? Stretch vertically because it's on the outside. Remember, something on the inside is horizontal. So that's the right shift. Something on the outside is vertical. Outside affects the outputs, the Y's. Inside affects the inputs or the X's, so that's horizontal. So the 2's on the outside is going to be a stretch vertically. I would like you to say by a factor of 2, and it's a stretch. What if that would have been a point? Well, I got one here. Never mind. And then what else? Up 3 or a shift up 3. Okay, and that'd be vertical. That's vertical because of the up. Okay, what about this one? Okay, it's got two things horizontal. So it's got a horizontal flip. Now I'd rather you write it out and not just abbreviate everything, but right now for time. Horizontal flip because of the negative. Shrink or compress, either one of those is fine. A shrink or compress by a factor of, and that's horizontal, by a factor of, well, you can say 3 because you already said shrink. Since you said shrink, you can say by a factor of 3. If that would have been a 1/3, it would be if there had been a 1/3 in here, that's a stretch by a factor of 3. Right? So you can say 3, because what would happen is, if you had x value of 2, it would now be out at an x value of 6. If you had an x value of -2, it would now be out here at -6. Okay, so it would be a stretch. So if it's a 1/3 on the inside, remember it's the opposite of what you would think. So if it's a 3, it's a compress or a shrink. If it's a 1/3, it would be a stretch. When it's on the outside, it's what you think it would do. A bigger number is a stretch, and a smaller number is a shrink. Okay? So the 1/2 would be a vertical shrink by a factor, you can say 2, right? It's going to shrink by a factor of 2. So if you have a 4y value, it will now be a 2. If you had an 8y value, it would now be a 4. Right? That's what it does. Okay, that's what by a factor of, because it's a multiplier, a divide, however you want to think about it. And then down 1. Okay? Now, this is the one that was tricky.
Oh,
okay. This is the one that was tricky. Okay, what do we have to do here? Is that what you were talking about?
Yeah, you have to factor.
We have to take out that 2. So now, and this is where I kind of messed you up yesterday, and I don't know what, I kind of went brain dead for a minute there when we were doing that one graph. But now when it's on the inside, when you have 2 things on the inside here, okay, like this, now the multiplication comes before the subtraction there, okay? So the first thing you'd want to list, and this is the only one that's tricky, and I mean, I gave you one of those, but on all these, it doesn't matter. Usually we just have the one thing on the inside. So this would be what's this 2 do? That's the first one. Shrink horizontally by 2. Okay, the -2 would be a right shift 2, and then up 1. Okay, so I just made up a couple of those, and I know you had a section where you were talking about those, and so hopefully that helps a little bit. But you want to do the order. You want to get the order of them right. Okay. Now the other thing I want to talk about is parent functions, because we kind of went through that pretty quickly that one day, and it's on page 70. These are on page 70, the parent functions. Okay, and so I've just got them written out here, these different ones. But all we're really doing is, I mean, it's so easy. If you see a squared, it's a squared. You see a cubed, it's a cube. You see the greatest integer. I mean, it's just what those parent functions are is that right there. Now we're going to be adding to those as we go through the year. But what I wanted to show you here is, okay, we spent a lot of our time in class doing the F notation, the function notation for our shifting. And so I just want you to see what that looks like then when you put that into the actual type of equation that we have. So if it's an absolute value function, then that would look like that, right? So the x minus 4 is on the inside of the function, so it's inside of the absolute value. The -2 is on the outside, the plus 3 is on the outside. If it's a square root parent function, it looks like that. If it's a squared parent function, the x minus 4 is on the inside of the squaring. If it's a cube, the x minus 4 is on the inside of the cubing. The weird one kind of is the 1 over x, right? What's the inside of the 1 over x function? Well, it's the bottom. It's where the x is. Normally, you would have the -2 probably just put up on top there, but it's easier to see if you kind of put it out front. So it's -2 times. So that's even the calc students sometimes have trouble with one like this. You know, what is that? Well, that's a 1 over x function shifted 4 to the right, okay? Because it's the same as all these. All of these are a shift of 4 to the right of the parent function. So this would be the basic 1 over x function, which was this one. It'd be the 1 over x function shifted 4 to the right, had a -2 in front, so that would be stretched, flipped vertically, or flipped and then stretched. Doesn't matter what order you do those. Okay, so what is it? Now, so let's talk about that. What does it mean to stretch. So here's where, on some of the homework, what you might have some questions on that we'll talk about is, what does it mean by stretch? Well, or if you had to actually graph one, or if you had to look at a graph and see if it's stretched, well, what you want to do is you want to pick out some points on that graph. So it's nice to know some important points on each of these parent functions. Like, for example, on this, it'd be nice to know, the v, where that's at. So if I'm moving that and shifting that, I'm focusing on that v. We don't deal with these that much, really. Square root, I think it's nice to know that. I think it's nice to know that the basic square root function goes there, and then it's not on here. But, to me, if I'm looking at the square root function, I'm looking at 4, 2, 9, 3. I'm thinking of some of those basic points, okay? If I'm looking at the square function, I think one of the most important things to understand about a basic square function, once you move it around, is wherever that vertex is, the normal squaring function goes over 1 and up 1, okay? And I think you had this in some of your homework. So if I was going to have if I gave you a parabola that was over here at 6, and over here was the point 7, 3, was on that parabola, what could you tell me has happened to that parabola? What has happened to that parabola? Well, what's the easy one? From the parent function. It's been shifted right 6, right? That's the easy one. What else has happened, though? Stretched vertically by a factor of 3. Because a normal parabola, right? We're talking skinny parabola versus fatter parabola, right? On stretched or compressed. So what happens is, a normal parabola would go 7, 1. Because the normal parabola, the one that's at the origin, goes over 1 and up 1, right? So if it goes over 1 and up 3, that means it's been stretched by a factor of 3. The 1 is changed to a 3. Does that make sense? Okay. So, and I think that's what they got into on some of them. Now, I apologize. We didn't quite have. We ran out of time a little bit yesterday, or I didn't think about looking at that. But that's what's going on. Okay. But it's because of your knowledge of the basic functions here. And same thing with the cubic. Goes through the point 1, 1, because 1 cubed, 1 cubed is 1. So you've got this kind of this middle point of the cubic, and then you've got this. So if you have a cubic, you can tell it's a cubic, but right in that middle point, you go over 1 and up 3. That means it's been stretched 3. Okay? All right. And the same thing would kind of be true here. This is kind of almost like your vertex of 1, 1, and then you can tell some of the other ones. Okay, same thing with this. This gap is 1 right here. Didn't you have a homework problem where it went over to 2? Was that one of the homework problems? Seems like I remember that. Which one am I thinking of? Help me out. Which one was it? 70? No, we didn't do 70. We didn't do 70. Okay, I guess that was one I was going to look at. So,
47.
Which one?
47.
47. Okay, and 47 already gave you the equation. Okay, okay, good. So I guess this wasn't on your homework. It was something I wanted to talk about today. Okay, so good. So we didn't have it. So anyway, we kind of understand what's going on there. So, and here's your greatest integer function. So I wanted you to be able to see that. All right. So 30. So let's talk about, what was that, 47? So 47 said g of x equals 3 minus greatest integer x, right? Now, if I was doing this problem, I would rearrange this. I would call this, I would do it this way. I would write it like this. I think that makes it much easier, right? So now you can see that it's a shift. Well, first it's a, what? Flip vertical, because it's got a negative on the outside. Outside is vertical, right? Outside is output. Outside is y value. Outside is vertical. Negative on the outside, it's a vertical flip. And then it's, what? Up 3. Up 3. Okay? Up 3. So I like to rearrange those sometimes. Now, as a matter of fact, I got an example here I wanted to look at. We're not going to, we'll come back to that warm up. Okay, so let's say I had this right here. Okay? And I asked you, because that 7 minus x is kind of a problem, the way that's written. We haven't really seen it. So rewrite this the inside especially. Rewrite the inside there so that you could get a sense of what the transformation is. Just take a minute to see if you can get that, okay? So this, if I have one of those, that'd be one of the harder ones. There's going to be plenty of pretty easy, I think, pretty basic transformation ones. If you know your basic transformations, you should be able to do pretty good, okay? But I might throw one in there that's a little more challenging. Okay, so what are you going to do? What's the first part you got to do? I think I would write this like this first. Right? And is that good enough? Because right now it looks like it's a shift which direction? It looks like a left 7, doesn't it, with the plus, right? But it's not. And again, it comes back to this one. Remember this one right here? We had to take out a 2, right? So what are we going to take out on this one? We're going to take out a -1. And then it's what? X minus 7 and then -2. Okay? So sometimes rearranging it, so this is which parent function? This is a square root function, right? A square root function was that sideways parabola. Now I told you I wasn't going to make you graph any of these, so you're not going to have to memorize from that standpoint. But it might be, if I give you a picture of a square root function, I might want you to know which one it is, okay, which parent function it is, okay, possibly. So you should look those over, okay? Most of them are pretty easy, cubic, squared, V graph, absolute value, So there's only a couple you probably need to really kind of look at to figure out. But so this one, so let's talk about the order. So what's the order? So what would you do first on this one? Flip horizontal. Remember we said you do the inside first, and of the inside you do the times before the subtract. So on the inside this would be a flip horizontal, be a right 7, and then down 2. Okay, so if we look, here's the parent function. So a flip horizontal would be there. A right 7 would be over here, and then a down 2. So it would be, it'd be something like this one here. Right? So a flip horizontal, a right 7, a down 2. And you end up with that. So like on that activity we did yesterday, it's like, there's only one parabola, all the rest of it, every other one is just a shift or a translation or something like that. Okay, now there is a name I didn't mention. I don't think it's a big deal, but I think if I mention this on the quiz tomorrow, I guess in the directions, you might need to know this. So we have 3 basic transformations, okay? We have our shift, either left, right, or up, down, okay? We have our reflection. This was the order that I wrote them the other day, or your flip, okay? And that could be vertical or that could be horizontal. And then we have your stretch, shrink, right? And that's it. I mean, those are the 3. Now, these 2 are called rigid transformations. Why do you suppose? They just take the whole picture and they just move it up. They just pick it up and move it around. They don't change the shape of it at all, right? So the shape, if you think of the graph, if you made the graph out of wire, right, it would not move. It wouldn't bend. It would just move around. Just pick it up, move it around. In both those, or flip it around. Okay, and then this one is considered a non-rigid transformation. Okay, so I'm not going to make you write that as something, but it might be in a direction somewhere where it talks about a rigid transformation versus a non-rigid transformation. Okay, like if I gave you, if I said, write an equation that would be a rigid transformation of the square root function. Write an equation that would be a rigid transformation of the square root function. So, there you go. Right? There you go. Or, there you go. So right, a right and then a flip vertical or something. That would be a rigid transformation. Okay? And if I said a non-rigid transformation, stick a 2 in front of it. Right? That'd be a combination. That'd be a rigid and a non-rigid, but it'd be non-rigid because that would have stretched then the square root. Okay, that's non-rigid. Okay, so just in case you see that term, you understand what that is. All right. So what else on the homework? If you have some other homework questions, we can certainly do it. Were you good on 11? I saw a lot of you had some nice pictures on 11. So you know what? Let's check those over just real quick. Okay. So here was 11. Okay. Well, some of you had nice pictures. You drew them all in the same graph.
Yeah. So they got a whole page.
Jeez. You labeled. Yeah, this is what should happen. You should have.
I labeled.
That drives me nuts.
That would be awesome. There we go. That's what.
So much work. What did you do?
No.
All those.
You did them all in one?
Yeah. I labeled them. I put in parentheses.
Oh, well, that makes
Dude, so did I.
Well, that makes sense. Yeah, that's what it is.
He's a.
Don't work harder.
Work smarter. Work smarter. Yeah. All right, now. Yeah, well, if we did it on a quiz, let's do them separately, right? But probably not going to be that way. All right, so I went ahead and graphed this piece. It's basically a piecewise, and so if you went on Desmos, the way to do a piecewise, you just put in the interval, and then the colon, then the equation, comma, and then you just put the different pieces in. It's a little different. You write it by hand, but that's how you do it. So anyway, got a piecewise here. So up to, right? You guys did it all in one, see if you can find it, whatever. Okay? Right, you got it, okay.
I have it at the end of every one.
Right, too, but again, these are rigid transformations here. What are we doing? We're just picking some of these important points, maybe these corner points. You just say, okay, let's take that corner point, let's move it 2 to the right, and then just draw it in from there. Okay? Then we've got a stretch. So again, now it's a vertical stretch. So what are you doing? I would take this corner point that's at 1, it's now going to be at 2. This end point that's at 2, now again, I'm looking at the y value because I'm thinking vertical here. So I'm looking at this, I'm saying, well, that's at 2, it's now going to be at 4 because, again, it's a stretch of 2. This one that's at 0 is still going to be at 0. 2 times 0 is still 0. And this one that's a y value -1 is now 2 times that, or -2. Okay? You do a vertical flip. You just take each of those y values and you just flip them down. This was at 2, it's now at -2. Okay, so you're actually looking at the different points, and like you say, your quarter points, stuff like that. Of course, 3, just move each of those points over 3. Here's going to be a horizontal flip, so just take that over there, right? And you're flipping those. 1/2. Now remember, on the inside, it's the opposite, right? So 1/2 should be a what? A stretch of 2 horizontally. So this x, now I'm looking at the x value because I'm going this way. So the x is 1, boom, going to be stretched to a 2. This x here is at 3, it's now going to be over here at 6. This x is at 4, it's now going to be over here at 8. So I'm not going to have you graph those, but I might do the reverse, right? I might give you these 2 graphs and say, okay, write the red one. Okay, write the red one. And then I'd want you'd have to figure out that, okay, it was stretched by 2 horizontally. That means a 1/2 goes in there. Okay? All right. So that was those problems. Okay. All right. Anything else? Anything on the homework there? All right. If we have some time, at the end here, you've got some questions you want to ask me. The answer book's up here, so if you want to check some things. You can do that. Okay, let's talk about the quiz just a little bit. Okay, I had that as a warm-up, but we'll come back to it. Okay, I tell you what, before we get one last thing on transformations, if you would turn to page 80, number 63. So this is what I was talking about a minute ago here. Okay, so this is page 80, this is number 63. So this is what I was mentioning. So here this is clearly an x squared as the parent graph, right? Now what has happened to it? Well, the obvious thing that's happened is what? Flipped vertically, right? So it's going to have a negative on the outside, okay? Now, what else? Well, they gave you this point, and this is what I was talking about before. In a normal parabola, this should go over 1 and down 1. But it doesn't. It goes down 3. So what's that mean? Stretched by 3. So that's why we would know that this is, and it hasn't been shifted anywhere because this is still at the origin. So we know that that would be that right there. Okay, a negative and a 3 on the outside because it's outside of the squaring, right? And we would have that there. Now, some people might say that if you stretch a parabola and it gets skinnier, isn't that the same as a compression? Well, it turns out that that's true. Not to confuse the issue, I would always go with an outside stretch if I can, because that's the easiest. But think about it. If I give you this, what does that 2 mean? A shrink of a factor of 2, which makes the parabola skinnier, right? Skinnier, okay? So that means where a normal parabola would have been here at 1, 1, it will now be in here at 1/2 1. You with me? Right? But what's another way to write this? What's another way to write this right here? Isn't that just 2x times 2x? 2x times 2x, isn't that 4x squared? Now, what is the 4? It's now on the outside. So it's a stretch of 4. Well, guess what? That means instead of going through 1, 1, it's going to go through 1, 4. Well, guess what? It's the same parabola, right? It's the same parabola. The parabola that would go through 1, 1 now goes through 1, 4. Guess what it's going to go through here? It's going to go through 1/2 1, right? So we can actually think of this, depending how it's written, you can think of that as a compression of 2 or a stretch of 4 vertically. And it's the same thing. It's the same thing, okay? I wouldn't get caught up in that. To me, I would focus on the obvious here, which is, okay, 1, 1's where it's supposed to be. It's stretched down -3. Let's put it there. Yes?
So when you say like the 4x and the -3x, when they're on the outside, why aren't there any parentheses?
That's a good question. I could put parentheses. I could go -3, parentheses, x minus 0. I mean, you know what I mean.
Would you need that minus 0?
Well, I wouldn't even need the x minus 0. I could just go -3 and then x squared, but they're just not needed. You're right. So, but why do I know that's on the outside? Because if I was to plug a number into there, I would do what? I would square first, and then the -3. So yes, that -3 is on the outside. On the outside. Yes. Okay. All right. So that I just wanted to mention that. So if we go down to another one, okay. So here's a V graph. V graph's the same thing. The normal V graph. You just look at the video. I'll have some review problems to do for the quiz and stuff, okay? Good luck. All right. I assume he's going to some competitions or something. Dual, okay. All right. Well, I guess even as a doctor's appointment, I guess it's okay to say goodbye. Right? All right. So a normal V graph, again, does what? It goes over 1, up 1, right? I mean, a normal V graph, absolute value, does that. Right? So this one, and a normal V graph should go over 2 and down 2, right? But what's this one? 4 -2. This is actually goes by 2s. So this goes over 4, and it should go down 4, right? But it only goes down 2. So what's that mean? It's compressed by a factor of 2. Now that's a vertical compression, so that means it's on the outside. So what would we have here? And it's not shifted, but it is flipped, so there's a negative. And what number would go here? 1/2. Because remember, on the outside is what we think it would do. So if it's going to compress it, it's a small number. Big number, if it was a stretch of 2, we'd put a 2 there. But this is a compression, because normally the V graph should go over 4 down 4, right? Because it has a slope of 1 on that V graph. But it only went, instead of 4, it went to 2. So that's a compression of 2. So you put a 1/2 on the outside. Okay? All right. So I'm not saying there's going to be very much of that on there, if any. But knowing something about the parent graphs can help you see those compressions. And that's when they give you a point like that, you have to think about what the normal graph would be. Okay, but most of the quiz is going to be, can you just describe, if you see how it's written, can you describe what it's doing? That's the main thing. Okay? All right. So, enough on the transformations. Let's review some of what we had. So, let's just walk through it. If you want to write this down, you can. So what have we talked about? What are the important things we talked about? So relation is just any set of ordered pairs. Okay? And I'm not going to necessarily ask for word definitions. I might give you kind of a fill in the blank kind of thing, or on some of this stuff, or as long as you can kind of describe it accurately. I'm not looking for exact memorization of things here. Function, it just means that each member of the domain matches only one member of the range. If you have a graph, you can do the vertical line test to see if it's a function. If you have a set of points, you can tell, right? We did some homework problems on that. Of course, domain and range, I know you did a lot of that in Algebra 2 class, the inputs, the outputs, the big ones on domain, you can't have a negative inside of a square root, and you can't have a 0 in the denominator. I mean, those are the big ones. Those are the 2 big ones you look for. So if I give you an equation, say, what's the domain? A lot of times it's all reals. If you have a squared or a cubed or something like that, it's all reals. If you have a fraction, you can't have 0 in the bottom. If you have a square root, you can't have negative inside the square root. So you solve that, and you eliminate those from your domain. And then the range is what are all the possible outputs. So again, graphs are easier to do the range. Zeros of a function, remember we said those are the x-intercepts. Zeros of a function are the x-intercepts. That's where the y is 0. So you just set the equation equal to 0. Now if it's a graph, that's easy. Just look for the x-intercepts. If it's an equation, you set the equation equal to 0, and then you solve. Maybe you have to factor, do some FOIL factoring or something, some kind of solve. Okay? So those are the zeros of the function. All right? So we did that. So, could be some problems like that on the homework. Okay. Then we've done a lot with this idea of symmetry and odd, even functions. Both graphically, if you look at a graph, it's easier because you can just look for the symmetry, right? If you have an algebra, then that's where we talked about putting the x, y, and negative x, negative y, that stuff in. Okay? And then even odd, remember, even matches up with y-axis symmetry, origin matches up with odd, origin symmetry matches up with odd functions. So if I ask, is it an even or odd function, it's a lot like asking, does it have y-axis symmetry or origin symmetry? It should just be able to do those tests for it. And I showed you that test using function notation, but if you prefer the first one we did with the x and the y and the negative y and that, then go ahead and do that. That's fine. Okay. Piecewise function, right? We did a homework problem the other day. I think Kale asked about it. We did number 63, where we just had to sketch that piecewise function. Or instead of sketch, maybe I just ask you for a function value, right? Matter of fact, why don't we look at that one real quick? That was, or let me just make one up real quick. if you have f of x, I mean, because one of the things, I guess, that goes with function, just finding function values, right? What's f of 2, right? What's f of a? What's f of German shorthair? And I think I've got that actually written down in a later slide here. No, I guess I don't. Okay. Oh, yeah, I do right down here. Yeah, I do. Okay. Yeah, so there's piecewise functions, parent functions, evaluate functions, that kind of thing. So if I give you an equation, that just means plug in a 2. If I give you a graph, just go to the x2, see what the y is, right? That kind of thing. But if I give you a piecewise function, say it's x plus 3 when x is less than or equal to 0, and it's 2x squared when x is greater than 0, and I ask for f of 2, where are you going to plug in the 2? You're going to plug it in to the bottom one, right? You're going to plug it into the bottom one. So if I ask you, that's a good question. I wouldn't ask you on those. Yeah, I wouldn't ask you that. I would only ask you the German shorthair and the a if it was just a regular function, right? It was just f of x, right? But for f of 2, yeah, I got ahead of myself here a little bit, and we'll go back to that other slide. But if I ask you for f of 2, you would plug it into this one. So 2 squared is 4 times 2, so your answer would be 8, right? So you got to plug it into the right piece. Okay, so just understand that. Otherwise, it's just plugging in. So down here, yeah, plug in a 2, plug in a 3a, where the x's are. Plug in a 2 plus h, where the x's are, and work it out. Plug in a German shorthand, whatever the case may be. Okay, so that's evaluating functions. Again, those 8 different parent functions, just kind of know their basic shape, be able to identify them, that kind of thing. Okay, and then, of course, the big one that we've been spending our time on today, the one with the transformations. Okay, those 3 different types of transformations. And be able to describe them mostly, be able to write equations of them. If you see a picture or I describe it to you, then you write, the transformation. Okay, like that kind of thing. Okay. And that's it. That's pretty much what we've been doing. So, like I said, the plan is just to make sure we have enough time. I don't plan on really going over any stuff or reviewing anything before we start. Now, that might be overkill. It might be, somebody might be done in 10 minutes, 15 minutes. It's not real long. Okay. But some of you might want more time. Okay. Half hour, 40. I think 45 minutes is going to be plenty. Okay. But you want to work carefully and not rush, and so I.
How many pages do you think?
It's just like front back.
Oh.
Yeah, it is not very long. Okay.
Would you say there's a majority of a certain?
No, I don't think so. I mean, I think to me, yeah, to me that's part of it. Maybe with function isn't a function is maybe a third. Stuff with symmetries, reflections. Maybe those are the big. Those are the big. Those are the big.
Well, there's probably some.
Well, I mean, to me, those kind of group together. I mean, those are kind of the big 3 stuff with functions and domain ranges. Yeah. So yeah, I haven't personally taken this. See, it's like usually that's what I tell my calculus. Was it easy? Well, I said I don't know. When I made the key, I got an 8. So I don't know. and it usually takes about that long. What? All right. So here we go. So here's what I did. I'm not going to go around and check this tomorrow. What I did is I've got some problems on the chapter review section at the end of the chapter. I picked out some that I thought would give you some review of these different things. So you don't need to graph any of them, okay? But if it asks for domain range, so if it says to draw the graph, don't worry about that part of it, or to sketch the graph. If you want to get on Desmos and check it or something, that's fine. But I tried to get some of each of those, like I say, the big 3, some of the stuff with transformation, some of the stuff with domain range, some of the stuff with zeros. I'm not saying this is a complete list of You know, if you do this, then that'll be everything that's on it. But I think it'll give you a pretty decent thing. Now, for you guys that were gone, and hopefully you heard on the video, when I assign these IXLs, basically all the IXLs I give you now, right now, they're going to be due. I need to pick a date. What is today? The 11th, 12th? So I would say somewhere around February 2nd. Is that Groundhog Day? I think that gives us, that's pretty close to halfway through the term. Pretty close. So what I'm saying is these IXLs that I've given you, we need to have those done by February 2nd. Now, these actually relate kind of to what we're doing now, so it wouldn't be bad to do them. But if you start doing one, you're like, oh, this isn't anything like the quiz. I'm going to wait and do it later. That was yesterday.
Now you have to do.
I've added some more. Is what I'm saying. But they're not due for 3 weeks. Right? They're not due for 3 weeks. So yeah. So and to be honest, so like tomorrow. So let's say you do get done with the quiz in 30 minutes. We got 20 minutes left. That's going to be what I'm going to say to you is, hey, work on IXL. So there'll be some times, there'll be various times where we'll say, hey, you can go ahead and work on IXLs for a while, or whatever, right? So there will be some class time, but tomorrow there will after the quiz for sure. Now we're going to do a little bit after lunch, kind of getting started with some trig, but there might even be some time for IXL work on that. Okay. All right, so you got 17 minutes here. You can work, check other stuff on homework, ask me questions. If there's some stuff that's still bugging you that I haven't really answered for you, come up and ask me.
Mark, do you want either of?
And it's always 80. It's always 80 on the IXS. You gotta get to 80. 23 through 34.
Yeah, you were like, I'm already there. I'm like, what?
Yeah.
23 through 24?
Yeah. I was like,
Yeah, he's like,
oh, that's
I'm already
really
on the third problem. I'm like,
Okay.
okay.
Oh, let me, has everybody got that copy? Everybody got this copy now? Yes, everybody? Okay. All right, I'll throw this up here. This was gonna be my warm-up. And this would, if you just want to glance at it real quick, doesn't matter. Or ask me about them. So this says, this row, these two right here, these sections right here is determine if it's symmetric with X, Y, or origin. And then is it even, odd, or neither? Is those right there. And so I was going to have you do those, but I'll just let you work and try them if you want.
You need either the homework sentence that.
What's that?
Do you need either the homework sentence that we missed?
No, I don't think I went around yesterday. And today I just asked and everybody said they did. So I just mark it down.
Not everybody said that they did.
No, yeah. No one said that they did. Right, true.
Oh, it's going. 7. That's right. Y equals -2. It's 26.
Charlie?
26. You made me
Don't make me say
you made me
that.
skip it.
Yeah. Don't make me say it.
Okay, you know, the Kearney Public Schools.
Yeah, that'd be interesting.
You're supposed to read the explanation and be like, no.
I would do absolute value on this.
Did you move the floor over?
I think you just type ABS. It would probably be under the math menu. There it is, top thing. But I think, but you can just type ABS
Okay.
also.
Gotcha.
It was under math, and I right arrow over the numbers. That was listed Now, no, and that reminds me, on the quizzes, on this particular quiz, we use calculator. Like I said, I'm not going to really make you graph any, but there could come a point where if you have a graphing calculator, that's different if you don't have a graphing calculator, right? I didn't really talk to you about a specific calculator, I think, other than like a TI-30, something like that. There may come some quizzes where I'll say, okay, no graphing calculator, right? So you can borrow one of mine. I've got some extras over here. Or I'll say just TI-30s or those kind of things, right? Especially if I was saying graph one of these, and it'd be a big advantage to have that. But so I'm glad you reminded me of that, because otherwise I just saw it right when you're starting the quiz, and then you'd have it. But I don't think it'll matter tomorrow. I'll as I finish up the quiz here, I'll see if it's going to matter.
So it's 5 and 1.
I don't.
Did you get that log?
No, when I answer